Hello guys, I'm Udaykumar. This video I'm going to say about implement Dijkstra algorithm to find the shortest path from single source to other vertices. So now we go to the program. So first of all, declaring a class and class name as graph. Then I'm going to declare functions to the graph. So first I declaring a function as add vertex, get vertex, contains, add edge, does edge exist, then iter. So now we see the def init of self, then self dot vertices, then def add vertex of self comma key, then vertex equal to vertex of key, then self dot vertex is vertices of key equal to vertex, then def get vertex of self comma key, then return self dot vertices of key, then def contains self comma key, then return key in self dot vertices, then using a def add edges of self comma source key comma destination key comma weight equal to 1, then self dot vertices of source key and into add neighbor of self dot vertices of destination key comma weight, then def does edge exist of self comma source key comma destination key, then return self dot vertices of source key dot into does point to of self dot vertices of destination key, then the def iter of self, then return iter of self dot vertices of value of. Next you're going to declare a class name as vertex, then you're using a functions declaring function to the vertex as a get key, add neighbor, get weight, does it point to. So now you see the first function ref init of self comma key, then self dot key equal to key, then self to point to. Next def get key of self, then return self dot key, then def add neighbor of self comma destination comma weight, then self dot point to of destination equal to weight, then get get neighbor of self, then return self dot point to dot keys of, then get weight of self comma destination, then return self dot point to of destination, then does it point to of self comma destination, then it will return a return destination in self dot point to. Next and using the function as a def for Dijkstra of g comma source. If unvisited equal to set of g, then distance equal to dict of from key of g comma float of inf, then distance of source equal to 0, then using a while function here, while unvisited is not equal to set, then closest equal to minimum of unvisited and comma key comma lambda v equal distance of v, then unvisited will remove from closed, then using for loop here, the for neighbor in closest to dot get neighbor of, then if neighbor in unvisited, the new distance equal to distance of closest plus closest dot get weight of neighbor. If distance of neighbor is greater than new distance, then distance of neighbor equal to new distance, then it will return a distance. Next you're going to do a menu driven program. So if g equal to graph, then it will print a menu again. Next it will print a add vertex of key, next it will print a add edge of for a source destination and distance, next it will print a shortest, next it will print a display, next it will print a quit. So if the while equal to if the while is true, then it will ask for the then it will ask for a input. So do equal to input of while what would you like to do. Next you're going to do a add vertex. So if the key if key not in g, it will add a vertex key, else it will print a vertex already existed. Next we going to add a edge. So if the source equal to int of do of 2, then destination of int of do of 3, then weight equal to int of do of 4. The source is not in g, it will print a vertex does not exist for source. If the elif destination is not in g, it will print a vertex does not exist for a destination. Else it will add a add edge for the source and add edge for the destination. Else it will print a edge already existed. Next we're going to do for the shortest. So elif operation equal to shortest, key equal to int of do of 1, then source will get a get vertex of key, then distance equal to extra of g comma source, then it will print a destination from the key from a format of key. Then for a distance v in distance for v in distance, it will print a distance to with the format of v dot get key command distance v, then it will print next it will display the vertices and edges. So print vertices of equal to end equal to, then for v in g, then it will print a v get v dot get key of, so that it will print the vertices. Next it will same, it will print the edges. Next it will create the program. So now that's all for the code. So now run the program. So if it is asking what would you like to do, so now we're going to give a add vertex 1. Next we're going to give a add vertex 2. Next we're going to give a add vertex 3. Next we're going to give a add vertex 4. So it is enough for the vertex. So we're going to give a add edge. So we're going to add edges. Add edges 1 comma 2 comma 10. The 1 is a source and 2 is a destination, and 10 is a weight. So next we're going to add again. So I'm going to give a 2 comma 2 3, then 20. So again going to add a edge. So add edge 3 4 25. So again I'm going to add edge. So add edge 1 4 34. So I'm going to give a shortest one. So this is the our output for the Dijkstra algorithm. So distance from 1 is 1 is 0, then 2 is 10, then 3 is 13, then 4 is 34. That's all this program. So this is the Dijkstra algorithm to find the shortest path from single source to other vertices. That's all guys. Thanks for watching.